Previous videos looked at where protons and neutrons are located and taught how to find the electronic configuration of different atoms. And now in this video we're going to take together the number of protons, the number of neutrons that we expect, and the electronic configuration to make something called the atomic diagram. This atomic diagram will show us where the protons are located, where the neutrons are located, and the probability of where we'll find those electrons. So let's see how to determine the electronic configuration of a variety of different elements. Step 1 is always to determine the total number of electrons present in the atom. Next, we need to determine the number of shells that are occupied. This is going to be determined by the valence shell. Everything below it will have electrons. And the valence shell is determined by, you got it, the period. Whichever period it's in will tell us how many shells there are. Once I know that, I'm going to go ahead and draw those shells out so that I can put the electrons in them next. So let's use oxygen as an example for the first two steps. So we see that the atomic number of oxygen is 8. That means that there are 8 total electrons for our element oxygen. Next, we want to see which shell it's in, which period it's in. It's in the second period, so we draw 2 shells. And just as a reminder, each shell has a maximum number of electrons that can be found in it. The first one is 2 times 1 squared, which is 2 electrons is the maximum. And the second one is 2 times 2 squared, which is 8 electrons maximum. In this case, we have 8 electrons, but not all of them will be in the last shell. We're going to remember that the lowest ones get filled, then we start filling up the next level. So we now know how many total electrons we have and how many shells will have electrons in them. Now we need to figure out how many electrons to put in each of those shells. We always start this process by putting the correct number of electrons in the valence shell. How do we find the valence shell? Again, it depends. If it's a group A, it'll be given its group number. If it's a group B, it'll have 2 valence electrons. For example, for oxygen, we know that we have 6 valence electrons because it's in group 6A. Then we want to put in all the other electrons in the lower shells. In this case, we only have 2 occupied shells. We've already put 6 in the valence shell. We're going to subtract from the original 8 that we had and find that there are 2 in shell 1. Now, is that more than the maximum? Nope, our maximum is 2. And then our maximum for the second shell is 8, but we don't have that many because recall we only have 8 total electrons. So we're done. We now have 2 and 8 as our number of electrons in each of those shells. All right, let's start with 2 very simple ones. We got hydrogen here, hydrogen with a 1 for its mass number. For these diagrams, we're going to show the whole system, including the nucleus and the electrons on the outside. In the nucleus, we know that we have 1 proton and no neutrons, so we're going to write 1 proton, 0 neutrons. And then we're going to look at the total number of electrons is 1. We're in the first shell, so there's only 1 shell. In that shell will be 1 electron, and we're done. That's it for hydrogen 1. Now you try helium. Go ahead and stop the video for a moment. Okay, let's start by drawing our diagram, placing the protons and the neutrons in the nucleus. Number of protons is going to be 2 because the atomic number is 2. The number of neutrons is also going to be 2 because 4, which is protons and neutrons, minus 2 is 2. For helium, we see that there are 2 electrons. There are only 1 shell, and it has 2 valence electrons. This is one of the exceptions. It is in group 8, but it only has 2 valence electrons because there are only 2 electrons available. It is a little bit weird because of its position. Let's try beryllium-9. So we start with putting the circle, put in our protons and our neutrons. We should have 4 protons, and 9 minus 4 is 5 neutrons. We have a total of 4 electrons because that's equal to the number of protons. Next, we want to find out how many shells we're going to have. We see that it is in this beryllium is in the second period, so it'll have 2 shells. Let's draw those in. Next, we find our valence electrons. We see that this is in column 2 or group 2, and in group 2 we get 2 valence electrons. We put those in the outermost shell, so we put a 2, and then we put all the leftover ones in the lower shells. We only have 1 lower shell, and we have 2 electrons left. We're going to put 2 there. And we always check to see that that one does not go over the maximum. And so our maximum there is 2, it's 2, we're fine. And that's it for beryllium 9. And now we'll do neon 20, and for neon 20, again we put our circle, we put 10 protons and 20 minus 10, so 10 neutrons. And then we put in that there are 10 electrons total. We're going to put our shells on here. We need to figure out how many there are. We're in the second period, so there are 2 shells. We're going to put 8 electrons in the last shell because it is a group 8A element. We put all of the leftover electrons in the lower levels, and so we're going to put in, we have 10 total minus the 8 that we put in the valence shell, and what's left is 2, and that is not over the max, so this one is fine. And that is it for neon 20. Okay, let's try sodium 24. So sodium 24 has 11 protons and 13 neutrons. Has a total of 11 electrons. Put those in the circle, and then we're going to make how many shells? Sodium's in the third period, so it'll have 3 shells. Let's draw those in. And now we're going to figure out how many valence electrons there are. Remember, valence electrons go in the last orbital that has electrons. Sodium is a group 1A element, and so it has 1 valence electron. We put 1 on the last shell. Now we're going to fill the lower shells. Again, we fill from the bottom up. We don't always fill every shell below it, but we do fill from the bottom up. So we know that the bottom one will definitely get 2, and then the next one we want to calculate. So we're going to say that we have 11 total. We're going to subtract out the 1 valence electron, then subtract out the 2 that are in the very bottom shell, and whatever's left goes in the second shell. In this case, we have 8 electrons, and none of those are over the maximum, so we know we did it right. And that's it for sodium 24. Okay, you should try sulfur 32. Pause the video for a moment. You should have gotten 16 protons, 32 minus 16, so 16 neutrons. We should see that it is in the third row, third period, so we should get 3 shells. It is a group 6A, so we'll put 6 in the last shell. We're going to put 2 in the bottom shell because we know that one will fill for sure. The second to the last one needs to be calculated. So we have a total of 16 electrons, minus 6 for the valence electrons, minus 2 from the lower shells, and we're left with 8 electrons in the second shell. And so this is not over the maximum. We've used up all of our electrons. Our total is 16, and so we've got it correct. And that is it for sulfur 32. Okay, go ahead and try argon 40. Alrighty, argon 40 has 18 protons, also 18 electrons. It has 40 minus 18 neutrons, which will become up with 22 neutrons. Argon is in the third period, so it has 3 shells. Let's draw those in. It is at a group 8A. That means we put 8 electrons in the last shell. We're going to go ahead and put 2 in the bottom shell. We're going to calculate how many go into the second shell. So for this one, we have 18 electrons total, minus 8 for the valence electrons, minus 2 for the lower electrons, and that leaves us with 8 electrons in shell 2. Again, we haven't gone over the maximum of 8, so this one's fine. We are done with argon 40. You also should always check that you have the right number of electrons when you're done. So we have 2 plus 8, which is 10, plus 8, which is 18, and that's what we expect. And now you can try calcium 40. Start by drawing the circle. We put in 20 protons, that's also 20 electrons. Then we put in 40 minus 20, so we also happen to have 20 neutrons. We see that calcium is in the fourth period, so we're going to put in 4 shells. And then we're going to start by putting in the number of valence electrons. It's a group 2A, so we put in 2. And then we're going to start filling in the lower levels. We're going to fill the first one with 2. The second one will have 8, and we need to calculate the third one. Remember, we're always going to calculate the second to the last one because we don't know how many it'll have. We know what the last one has. We know all the lower ones will be filled, but the second to the last one needs to be calculated. We have a total of 20 electrons. We've used 2 for the valence shell. We're going to put in 2 in the lowest one, and then 8 in the next one, so that's a total of 10. So we have 20 minus 2 minus 2 minus 8, and we're left with 8 electrons in the third shell. Notice this is not a filled one, but as long as it hasn't gone over the max, that is okay. It is quite common for the third one to have less than the 18 that is the maximum. So let's make sure that we have a total of 20 electrons now. We have 2 plus 8 plus 8 plus 2, and that is 20. So we are done. And that is calcium 40. So remember, anytime you're looking at these, we always do the valence electrons, then we do all the lower shells, but the second to the last one, we always have to calculate by finding out how many electrons are left for that position. Again, the second to the last one must be calculated. All right, go ahead and try iron 54. Here you draw a circle. We put in our protons at 26, put in our neutrons at 28, and I usually like to just write how many electrons total we have, which is 26. Next, we find out how many shells we should see, and we see that iron is in the fourth shell, so I'll draw 4 shells. We see that this is a B type, so all the B ones have 2 valence electrons. We just put 2 on the last shell. Okay, fill in the lower shells. We get a 2 and an 8, and now that leaves us with the third shell, which we must calculate. So we have 26 electrons total. We've used 2 for the valence electrons, 2 for the lowest shell, 8 for the second shell, and that leaves us how many on the third shell? So we get 26 minus 2 for the bottom shell, minus 8 for the second shell, and that leaves us with 14 electrons in the third shell. None of these have gone over the maximum, so we have a maximum of 2, a maximum of 8, a maximum of 18, and a maximum of 32. And we haven't gone over any of those, so we know that so far we are correct. The last step again is to check that we have the correct number of electrons total. We should have 26. We have 2 plus 8 plus 14 plus 2, which is 26. Okay, let's try arsenic 65. We draw the circle, we put in 33 protons, 32 neutrons, because 65 minus 33 is 32. Then we put in how many shells we need. Arsenic is in the fourth period, so there's 4 shells. Now we need to figure out how many valence electrons to put in. And we're going to put in 5 because this is a group 5A. On the lower shells, we're going to put 2 and 8. Then we need to calculate the second to the last shell. We'll start with our 33, subtract out 5, subtract out 2, subtract out 8, and you are left with 18 electrons in the third shell. That electron shell is now filled, but not over the maximum. Now we check that we have a total of 33 electrons. We have 2 plus 8 plus 18 plus 5, and that is 33 electrons, so this is a correct answer. That's it for arsenic 65. Please try krypton 75. We draw our circle. We put in that we have 36 protons, 75 minus 36, which is 39 neutrons. We need to find out how many shells to put in. Krypton is in the fourth shell, so we put in 4 shells. krypton is in group 8A, so you should put in 8 valence electrons, fill in the lower 2 shells with 2 and 8 electrons, calculate that third shell, and that is going to be 36 total electrons minus 8 valence electrons minus 2 and 8 for the lower shells, and we're left with 18 electrons. And so we see that we have our total of 36 electrons by adding 2 plus 8 plus 18 plus the 8 valence electrons, and that gives us a total of 36 electrons. So we know that we have everything correct because nothing is over the maximum, and we have the correct number of electrons total, in this case 36. That's it for krypton 75. We have a few more to try. Okay, pause the video while you try these 3. All right, rubidium 81. We see that rubidium 81 has 37 protons and 37 electrons. It is 81 minus 37, which is 44 neutrons. It has 5 for its valence shell because it's in the 5th period. We're drawing all 5 shells. We're going to put 1 electron in the last shell because it is a group 1A. That's our valence electrons. We have 1 valence electron. Then we're going to put in lower ones. We're going to put in 2, 8, and 18. Again, those are the maximums for the lowest ones. In this case, the 4th shell we need to calculate. So we're going to start with our 37 electrons, subtract out 1, 2, 8, and 18 to find that there are 8 electrons in the 4th shell. We add these up, 2 plus 8 plus 18 plus 8 plus 1, and you should end up with 37 electrons total. None of them are over the maximum. Remember, our maximums are 2n squared, so 2, 8, 18, 32, and 50. And so we're good with all of those, and we have our completed atomic diagram for rubidium 81. Now let's do one for molybdenum 84. To start off with, we have 42 protons, and we have 42 neutrons in the nucleus. We're going to draw out 5 shells because it is in the 5th period. And this is a group B, so it's only going to have 2 valence electrons. So we'll put a 2 at the end. The lower shells get 2, 8, and 18 electrons. And finally, we're going to look at the 4th shell and calculate how many it should have. We have a total of 42 electrons. Subtract out the 2 for the valence electrons, then all the ones in the lower shells, 2 and 8 and 18. That's a total of 42 minus 30. That leaves us with 12 electrons in the 4th shell. So let's calculate that we have the correct total. We have 2 plus 8 plus 18 plus 12 plus 2, and that is a total of 42. Nothing's gone over the maximums. Maximums again are 2n squared, so that's 2, 8, 18, 32, and 50, and nothing is over that. And the last one is going to be silver 92. Put in the protons, which is 47. We end up with 45 neutrons. Silver's in the 5th period, so 5 shells should be drawn. It is a group B, so we're going to put in 2 valence electrons. The lower shells will be filled 2, 8, 18, and we calculate that 4th shell, and that is going to be 47 minus 2 minus 18 minus 2, or simply 47 minus 30, which is 17. And so we should find our total again just to check. 2 plus 8 plus 18 plus 17 plus 2 is 47. Nothing went over the maximums are 2, 8, 18, 32, and 50, and so this is a correct atomic diagram for silver 92. And that should be the last one on your list.